Hello, in this video we're going to deal with the ambiguous case triangle, which I've also named the socially awkward triangle. So let's look at this question below. Given triangle ABC, where angle A is 35 degrees, B is 12 centimeters, and A is 10 centimeters, we want to find angle B. And so I've drawn a scale diagram down here using GeoGebra, and this is perfectly valid. And notice I've given angle B the value B2, and we'll see why that is in a second. So the question comes up is, well, why is this called the socially awkward triangle? Again, one of the tools we have for identifying if we're going to use sine law or cosine law is naming the triangle based on the angle side information that's provided. And if we look at this one, we see that this is, if we start here at the A, we see it's a side-side angle case. And this is, I remember when I did my first teaching placement, the teacher I was working with said, Paul, you have to always write this on the board, side-side angle, because if you write it angle side-side, we see the acronym is not ideal. But it does help us remember that this is a socially awkward case, which means we have to make a special consideration when we're dealing with an angle side-side case, when we're working with the sine law. And that's what this video is all about. We're going to look at how to deal with this added consideration. And let's dive into this problem and see what that added consideration is. So when I look at this triangle, what I notice right away is that I have angle A and I'm given the opposite length. And so when I have an angle in the opposite length, I think of sine law right away. So if I'm interested in finding angle B, if I go across, thankfully I'm given length B, so that means I can set up sine law here. Now I'm going to set up sine law such that B2 is in the numerator. So sine B2 over 12 is equal to sine of 35 degrees over 10. And now I'm going to do a little rearranging. So sine of B2 is equal to 10 sine 35 degrees over, that's 12 sine 35 degrees over 10. And I really want to stress the point that we should be able to type this in our calculator in one step. So we should be able to calculate, get our calculator out and work out this right-hand side in one step, and then take the sine inverse of that. A nice little check here to remember is that this value has to be less than or equal to 1. Okay, and so for those of you that have only studied right angle triangles in Sakatoa, you might not quite yet know why it could equal 1, but we know that the numerator represents the opposite and the denominator represents the hypotenuse, and the opposite must be smaller than the hypotenuse. So if I get my calculator out and I type this in, I see that I get an angle of approximately 43.5 degrees. And this is where I stop and scratch my head, because I always want to go back and look to ask, does my answer make sense? And we can see here, if we look at the diagram, B2 is definitely not an acute triangle, or sorry, an acute angle. And now remember, I mentioned at the start that I drew this diagram to scale. So you scratch your head and you say, well, what's gone wrong here? So this is why we talk about what's called the ambiguous case. Because, interestingly, there's a second way we could actually draw this triangle. When we're given an angle side-side case, think of it like this. So here's my angle A of 35 degrees. So here's my length B, which is 12 centimeters. Now imagine the length A as being a point on a circle. So here's my length A, and notice how this point can move around. So the angle is fair. So here's my 35 degree angle. Here's my 12 centimeters. Here's my length A, which is 10 centimeters. And notice, if I swing this down, notice that it connects with that horizontal line here at the point B1, but also here. So in fact, the reason why we call this an ambiguous case is because I don't know which case we're talking about. Are we talking about this triangle, or are we talking about this triangle? And that is what the added consideration here we need to take into account. So like I said again, in this diagram, imagine this wasn't given, but I drew this. We know that B2 is an obtuse triangle. What I missed was the fact that, it's a small diagram here, is that this is another valid diagram. And in fact, the work I've done here corresponds to this case. So this work here, and let's just highlight all of this, actually corresponds to this case of triangle. Because we can see that this angle here makes sense to be 43.5 degrees. So then the question naturally comes, well, how do I deal with this case? So in fact, let's make a little correction here. B1 is equal to 43.5 degrees. So then the question comes, well, how do I find B2? And this is what often happens. When students are learning the ambiguous case, they first encounter it when they're learning sine law and cosine law, but they haven't learned a concept called rotational angles yet. So what a teacher often says is that, well, given an angle side-side case, if you need to account for both cases, what you do is the following. Your calculator will always give you the acute angle. You need to find the obtuse angle case. And to find the obtuse angle case, what we do is we take, so the obtuse angle case, what we do is we take 180 degrees and we subtract the acute case from that. So B2 is actually going to be approximately 180 degrees minus 43.5 degrees. And that gets us the value of about 136.5 degrees. So again, this is a socially awkward case. The reason why it's socially awkward is because in fact, given an angle side-side, you can draw two possible triangles. If you use sine law, your calculator is going to work out the case where the angle you're solving for is the acute case. You need to be very careful and remember that there is actually an obtuse case possibility. And to get that value, we need to take our acute angle and subtract that from 180 degrees. So of course, this is the trick we tell you, but then the big question comes, well, why? And in the next set of videos, I'm going to show you why we actually perform this process. In order to understand this, we need to better understand something called rotational angles and how it is we take the sine, cos, and tan of angles that are bigger than 90 degrees. I hope this video helped.